probably have some pretty mad things, like it rotating in different ways or spinning like that. And clicking apply will basically say, clicking apply in the top right hand corner for the object will basically say, go to my stored prefab and overwrite it, like this is now our master one. So what you'll notice here is my animation for this rocket is now sort of spinning. And what I do here is when I'm playing, every time I fire the rocket, all of them are going to be spinning now. Very cool. Not quite what we want to do, but it's just an example of the way that you can just animate pretty much any component that you want in Unity and then just apply that to one master copy and just duplicate that hundreds and hundreds of times. Cool. So that's kind of not what we want to do. So I'm sure some of you have made some very beautiful creations in your scaling and resizing and varying of colors, making your rocket rainbow colored or whatever it may be. So what I'm going to get you guys to do is select all of the sort of different shells inside your animation window, hit backspace, and basically get rid of them. So we're back to the start. So I'm very sorry if you made something very, very gorgeous, but it only takes a couple of minutes to sort of remake it, I guess. We're going to do things properly. What we're going to do is we're going to use a very simple rocket. Hang on. We're going to use this sprite sheet where we have our series of sprites. Basically going to cycle through them. We're going to use our flip book and go to the next one, then the next one, the next one, and basically flip through this flip book. Now if you remember, we looped that animation clip. And because we looped that animation clip, basically it's going to get to the end and then go back to the beginning. So it's kind of never ending over and over again. So what we're going to do here is if you select the rocket, go down to the animation clip at the bottom. I want to go to Add Curve, Sprite Renderer, and then Sprite. So Add Curve, Sprite Renderer, because we want to animate something there. We're going to animate the sprite. So what we're going to do in every keyframe is take this sprite of this rocket and swap it out for the next one. Then we're going to swap out for the next one. We're going to swap out for the next one. So it's like a series of still images suddenly kind of swapping each other out very, very quickly. And add the little sprite button. So now what we should have is we should have rocket 0_0, and we're animating the sprite. Now when we do that, what you'll notice is it will show a little preview of what our sprite looks like. It also shows you what the keyframes look like from the start to the end. So basically it's taking the same sprite and it's saying, you look like this at the beginning and you look like this at the end. And what we want to do ultimately is basically fill in all of our sprite frames into there. So what we can do now is basically, if we delete the last keyframe, so go to the last keyframe and select it, and click backspace. We then want to go into our folder, select our rockets, but do it in order. So basically select rocket 0 to rocket 7, and drag and drop them into the timeline. So select them and drag and drop them. What you should notice is all the little dots will pop up. So I'll do that again. So basically, select all of your frames, so all your frames in that sprite sheet. So rocket 0 to rocket 7. Select the top one, or select any of them, and drag and drop it, so at some point. And kind of line it up with the beginning one as well. So you kind of like attach it onto the end. So you should have something, when you bring it in, that looks like that. That rocket has too much fuel, so it's kind of going a bit mad. But we can see it's actually cycling through those frames. I see some people laughing over there at how, how wild it is. So currently this is fine. It's going through and it's using those individual frames and looping over again, but it's currently doing a bit too fast. So what we can do is we could go in and we could individually move every single frame just a little bit wider, but that's going to take time. And if I was mean, I'd let you guys do that and then show you the quick way on how to do that. So what we're going to do is we're going to change the sample rate. So the sample rate is currently at 60, so it's basically going to process through 60 frames a second. So it's going to go through and it's going to loop through, and it's going to do it very quickly. So if we wanted to basically slow down this loop, we change it from 60, and we're going to halve it to 30. So this is going to be independent. So now when you change to 30, it's currently a bit better. Now I still think that's a little bit too fast. You might think otherwise. But now I'm going to change that from 30 down to 15. So now we have our rocket, it's looping through the flames, and it has a little burst behind it. Cool. And it actually looks a lot nicer. Now you wouldn't be able to animate that in Unity, because what it's doing is it's basically changing how the pixels look of each individual rocket flame. But what we're doing is using the animation system and the sprite slicing to basically overlap them and have something like that. Has anyone not got that? Have they got something similar? Is there flames going like super quick? Or has everyone got sample rate at 15? It's kind of like a lot slower. Lots of serious faces working on their rockets. Cool. Awesome. So we should now have a rocket with flames basically flying like so. And what I want you to do is basically stop that animation from playing. Select the rocket and click apply. So what it's now going to do is it's going to take all that animation data, basically everything we've done, or we swapped in, apply it to the master copy that's in our project folder, so in this prefabs folder, and I want you to delete the one from the scene. So select the one in your scene, apply it to say this rocket here now overwrites the master one, delete that one, and then we now have that master one. So now whenever I fire a rocket, it's quite difficult to see on my screen. Hang on, if I maximize. It looks a lot better. It's a lot less static. It's actually kind of like going through that loop, and the flames are actually kind of traveling. So all these little subtle things that look quite cool. And they get a bit wonky if they spawn on top of each other, so yeah. Everyone okay with that? Has anyone not got that? Pardon? Apply doesn't do it for you. Right, okay, so everyone has little flames flaming, I guess? Hope so. Cool. So our game's fine, we have little flames flying. Next thing we're going to do is we're going to add in some asteroids. We're going to prep some asteroids. We're basically going to spawn them to go towards our ship, and we're going to blow up some asteroids a bit later on. Cool. So let's do that. So what you want to do is you want to get into your scene view, so we have our ship, and we want to go to our sprites, select asteroids, so we're going to select the asteroid sprite sheet. And you can see the little preview there is kind of broken up just because there's transparency around the outside edge. And I want you to go up to the top where you have the import settings for the asteroid and set texture type to be sprite, sprite modes to be multiple, because we have more than one. Pixels to units to be 30, because that's basically what we've used for the other pixels to units, 30. And click apply. So the filter mode, you can basically set it to be bilinear or point. Point is a bit better for pixel art and something we could have done a bit earlier on. But either way, it'll be fine. So if I had a look at bilinear, yeah, that's fine. We can leave it as either. Cool. So what we're going to do is we have these asteroids. They're all sprite. They're all multiple. If you select the asteroid sprite sheet and go to the sprite editor, where they're going to slice them up. So out of grid and auto, which one's going to be the best one for this? I'm going to start questioning you guys. Auto, yes, cool. So if you go to, with the asteroid sheet open, go to slice, go to a type of automatic, and click slice. We now have 3 asteroids all prepped and all ready for us to use. So we now have 3 asteroids sliced up, and we need to click apply. So if you click apply after that, what you'll notice in our project settings, so we have the little drop-down list, and we basically now have 3 different sprite sheets. Now the reason why that gets blurred is because it's blowing up a 17 by 17 pixel sprite to basically fill that size. But you can see we have some slightly different asteroids. So we've used a sprite sheet to basically cut up our ships and bring them all in and bring in modular parts. We then use sprite sheets to basically play through an animation, and now we're using a sprite sheet for different assets completely. So you can use a sprite editor in many different ways to make your 2D games. Cool. So we now have a couple of asteroids. So what we want to do is we want to go back to our scene, and with asteroids 0, 1, and 2, drag and drop them into your scene, and just position them anywhere. And remember, you need to select the asteroids and put their sorting layer onto foreground main. So they're all being rendered in front of the background, but on the same layer as the spaceship. So what we're going to do is almost exactly what we did with the spaceship and with the rockets. We're basically going to prepare their components for being collided with by rockets. We're going to put colliders on. We're going to put on rigid bodies and stuff. So you can see in making games, it's kind of like using and reusing the same components, but kind of tweaking them depending on what you're using them for. So this is going to be a kind of a bit of an independent bit. So what I want you to do is I want you to add a rigid body 2D to each asteroid, set all their gravity to be 0, and add a collider for each asteroid as well, and kind of tweak it. So in the end, you should, like what we did with the rocket, where we added a rigid body, we then set its gravity to be 0, because we want to push its gravity by ourselves, then add in a collider. Now I'm going to do it and talk it through, but if you want to kind of like rush ahead and start playing around with the colliders and things like that, that's cool. So what I'm going to do is I'm going to start with the smallest asteroid, which is the easiest one to do. I'm going to go to Add Component, Physics 2D, Rigid Body 2D, so it now has some physics. I'm then going to set its gravity to be 0, and I'm going to add another component. So what I'd normally use is polygon collider, because I want to sculpt the collider so it wraps around the asteroid or wraps around the rocket or whatever it may be. So what I want to do is I don't want to do that. I want to use a circle collider, because I have a quite circular asteroid. I want to basically get a circular collider and use that instead, rather than me clicking and being very precise with it. So I'm going to set a circle collider, and that is roughly the same size. That's okay for me. So that's asteroid 1 done. Cool. So the small asteroid is now done. I'm now going to focus on the next asteroid. So the next asteroid, I'm going to do pretty much exactly the same thing. Now, another little trick in Unity is as we're starting to build up our scene, we're having lots of different components and things, it's kind of a bit of a nightmare to navigate around it. So one little trick you can have is F for focus. So if I select, for example, asteroid 0, and I want to then focus in on that particular object, hitting F will basically focus in and center it right in the center of the screen. So it's really useful for selecting a different asteroid. Hitting F even zooms in and scales in and out depending on what you've selected. It's a useful thing, especially if you have a massive game. So I was working on a platform game, and the level we were working on was very, very long. And eventually we were just kind of scrolling all over the place trying to find like the end of the level, and then we had to tweak something at the beginning and then go back to the end and tweak something. Then when we learned this F thing, we could then just select an object, hit F, and then just zoom straight to it. And it's very, very useful as you get sort of more complex scenes and more complex games. So I've got the small asteroid, now I've added a rigid body, set its gravity to be 0, now I've added a circle collider. I'm going to do the next asteroid up, so asteroid 1. So let's add a physics 2D, rigid body 2D. I'm going to set its gravity scale to be 0, like I did before, because I don't want them to drop automatically. And I'm going to add a circle collider. Now what you notice with a circle collider is it's kind of a bit offset, and I'm not too happy with that. I'll basically need to refine that in and pull it in a bit more. So what I'm going to have to do is I'm going to have to go into my circle collider settings, change the radius, so change the radius to, for example, 0.55 perhaps, and it's slightly offset as well, so I'm going to change the center point of X to be 0.2. Oh, okay, that's moved it the wrong way. So minus, no, a bit too much. Minus 0.04. So now we've used the circle collider for this asteroid because it's fairly circular anyway. And radius 0.55, and I've recentered it to be around the center. So we now have small asteroid, medium asteroid. Now this is the one where I have to do most of the clicking, because a large asteroid, it isn't a round shape and it isn't a box, so I'm going to have to use a polygon collider for it. So if I select this asteroid, I'm going to add the component of a rigid body 2D, like I've done a couple of times already, set its gravity down to be 0, and I'm going to add component, physics 2D, polygon collider. So we now have a close best fit, but we still need to click it. So what I'm going to do now is hold shift and basically rescale the collider and form it all around. And then everyone's either using sort of like the circle colliders and polygon collider combination like I am, or they're doing their own way, or they're just putting boxes on everything because they're lazy. It doesn't matter, as long as you have some form of 2D colliders around your asteroids. So do I want to turn on sticky keys? No, I do not. Awesome. So we have, oh, yeah, that's fine. Cool. So who here's got 3 asteroids, all with colliders and all with rigid bodies? Some people still clicking. You're nodding, that's cool. Nodding is a good sign. You're nodding as well. Is anyone else nodding? These chaps, cool. Okay, that's cool. So we have 3 asteroids, and what we want to do now is we want to give a script to all of them as well, because we need to give the asteroids some form of behavior. Actually, let's do that in a bit. Let's do something else first. So what I'm going to do now is I need to save these asteroids as master copies. They basically need to be master objects, which I'm then going to create on runtime, because I want to constantly spawn asteroids and have them go down towards the player. So in our prefabs folder, very, very easy. Select one asteroid, drag and drop it in, and let go. Select the next asteroid, drag and drop it in, and let go. Select the next asteroid, drag and drop it in, and let go. So asteroids 0, asteroids 1, asteroids 2, and the rocket. So we now have 3 different sized asteroids, all looking slightly different, all with rigid bodies, all with colliders for their own specific shapes, all ready to go, all ready to be used. Awesome. Cool, so you can probably guess what I'm going to do next. I don't need the ones in the scene anymore, so I'm going to select the asteroids, and I'm going to delete them. So basically, I'm going to make them go away now. Asteroids delete. So the next thing that we're going to do is, now that we have our asteroids we're going to spawn, We now need where we're going to create them. So we now need spawn points. We now need locations where we're going to say every, for example, 0.5 seconds, create an asteroid at this point, or create an asteroid at this point. So we're going to use a little trick, and this is something that I use pretty much in every game and anything that I do with Unity, is basically just use a heck of a lot of empty game objects. So if you go to game object to the top and go create empty, what that does is it creates a game object with only the properties of a coordinate. That's all it has. And these are really useful in game development. So whenever I make a game, I just use tons and tons of empty game objects because they're very useful because they're a particular coordinate in your game somewhere. They could be a rotation, they could be a scale. They don't have a renderer, so they're not being rendered, so the GPU is not using them. There's very, very little on the CPU because it's just an X, Y, Z 3 times. So it's like 9 numbers. It's really, really, friendly. Yeah, they're just really useful things. And I always use them for spawn points or directions that players should be facing and things like that. They're really, really handy things to use. And I'm going to use these as spawn points. So I'm going to create 5 spawn points above my spaceship somewhere and basically position them. Now, the trouble with empty game objects is if I select off of it, so say like I place my empty game object here. If I select off of it, I have no idea where it is. It's completely hidden now. I'm going to have to kind of guess whereabouts it is. Can anyone tell me exactly? Has everyone forgotten already? I've forgotten. Whereas if I select them again, then it's going to show me where that particular location is, that particular point. So in the 3D space, I can see exactly where in this 3D world it's going to be. In 2D, basically, I have no idea where it's going to be. So one little trick that's been in Unity since, I think it was introduced at the beginning of version 3 of Unity, and it's been in for years, that I show people who've been using Unity for years and years and years, and they're blown away that this was in the engine so long, is if you select an object, if you go to the inspector section at the top here, this little cube with the arrow is actually a button. And if you select that button, you can basically put a little label or an icon to any game object in your scene. So you can label up your spawn points and you can label up and basically show hidden game objects. And lots of people are like, this would have saved me so much time and effort in just using this simple system. So if I select the blue label, for example, well, you'll notice that my empty game object, when I select off of it, it now has a label to say whereabouts it is and what the name is of. So if I call this spawn point 1, I know where spawn point 1 is when I select off of it. I can go over and build my other game. I know exactly where it is. I can even select that label and it instantly select it. It's really useful to use. So what you'll notice is that the label is probably a little too long. So what I can do is I can go to the icon in the corner and I can say instead of being a label, which is like these strips, be one of these pointers. So if I choose this red cross or this red sort of inverted square, what you'll notice is that I now have a red point to say where my spawn point is, which is really useful. Another thing you can do if you want to customize it a bit more is you can go Other, and basically in the Other window, what it's going to show is basically all your textures and all your sprites. Actually, all your textures that are in your project folder, and basically choose any of these. So if I wanted, for example, an asteroid symbol, I could set the asteroid symbol or the icon I'm going to use later on when I build a Windows phone as my particular spawn point location. That doesn't render in the game view. So if you go to the game view, there's no spawn point. It's simply just so you can see where your empty game objects are. So I highly recommend giving your empty game object a red sort of like diamond. Cool. So what I want you guys to do now is I want you to make 5 empty game objects. So basically you could just take the first one, duplicate it, take the next one, duplicate it, and create 5. Perhaps even name them. So I've got spawn point 1, spawn point 2, and spawn point 3, spawn point 4, spawn point 5. Cool. Now there are all the current locations. What I need you to do is space them out. So what's going to be useful in spacing them out is basically having the game view next to where your scene view is. So in your scene view, you're moving things. In your game view, it's basically showing you what your game's going to look like at the end. So ideally, you want to position them all along the top somewhere. So basically have a couple of spawn points at the top of the screen. Now obviously, even though I have my empty game objects and basically they are all dots, I can't see them in my game view. However, what you can do is you can click the little gizmos button up here, and doing that will basically now show these little empty game objects in your scene view. So you can kind of like see and preview where they're going to be. So I'm going to position this one at the top here. This one at the top here. And this one there. If I now run my game on maximize on play, I can see I have 5 spawn points for my asteroids. Now I've got a bit of space on the side, and that'll be something that I'll be able to play around with later on, but I have my 5 spawn points. Now when I finally build my game, those spawn points won't be in there, they're just a Unity only thing, as in those little red dots. That's kind of just a thing so you can see where they're going to spawn. But when you build your game, those won't be included. Cool, so if you have something a bit similar to that, preview it and make sure you have 5 little diamonds hovering just beneath the top. These are going to be the random spawn points, because we're going to randomly pick one, randomly pick an asteroid, and then basically take that random asteroid, take that spawn point, and kind of instantiate them together. Or instantiate the asteroid where that point is. Yeah. Cool. Are you following along okay? You're taking it in turns, right? You're doing both projects. It's twice the learning. Okay, cool. So when 2 spaceship shooters are shipped on the store, you're taking royalties for both, right? So when both the games are shipped, you're basically going to take a cut from each game, right? Yeah, you're doubling your cut size. Okay, cool. So has everyone got something that looks a bit like this? It doesn't matter if they're in a perfect line, as long as they're kind of spaced out, they're 5 separate points, and they're all sort of about the top of your screen. Speak now. Right, so we have our spawn points, and what we're going to do now is we're going to hide them. So currently our spawn points are here, and whenever I play a game and I can see my enemies spawning or see things spawning, it kind of breaks your immersion. So what we're going to have to do is we're going to hide these things from spawning out of view. And this is really easy. All we're going to do is we're going to select the 5 spawn points. Select all 5 spawn points. Then in Unity, basically move them up. So it's kind of like hiding and cheating, but basically just drag them up so you don't see them anymore. So the spawn points are still there. They're just kind of hiding just slightly off screen. So just like that. So what you should see is when you maximize on play, they should no longer be there. But technically they are. They're kind of in this sort of like empty space bit at the top. They're just outside of view of the camera. So we have the spawn points there, and the asteroids are going to be created, then they're going to go down. So they're going to come into view. They're not being created in front of your eyes and kind of ruins the game a little bit. Cool. So what we're going to do now is that. Cool. So what we have is if we create another empty game object, create empty, call this one the manager, Basically, a good practice for making games is in Unity is have an empty game object called the manager and put all of your important scripts and all your important things on that. So put things that control your audio when it's playing, menus, high scores, enemy spawning, things like that. Because then when I'm making a game, I then know the manager is the one place where all the important things are on. I can then go there. I don't have to go through all my objects to find where all my audio things are being held. The manager is always a pretty good idea to have. So in this case, we're going to put a script on the manager which is going to spawn the asteroids and say, every 2 seconds, create a new asteroid, and so on and so forth. So we're going to make a brand new script in our scripts folder, and we're going to call this asteroid spawner. So a brand new script, and drag and drop that onto our manager. So our manager should now have a transform, because it's an empty game object, plus an asteroid spawner script. Awesome, cool. And we're going to open that up. We're going to write some code. Complete mono-develop is going to open. Okay, it's not. So now that we have the asteroid spawner script opened, what we're going to do is we're going to add a couple of variables. Now we're going to do a thing called a game loop. So in Unity, things like physics or things like time or things like update are basically every single frame are going to be looping through. It constantly holds it. Now, okay. So what we're going to do is we're going to make our own game loops, our own thing to say, run this code, wait 2 seconds, run the code again, wait 2 seconds, run the code again, wait 2 seconds. Kind of like a conveyor belt constantly going through and processing or creating things. So for this, we need to set up a couple of variables at the top. So we're going to set up a float called delay between spawning. So this is going to be that little gap, that little thing that says create the asteroids, how long it waits until it creates them again, how long it waits. So it's going to be constantly looping over and over again. So another thing that we need to create is public game object asteroid array. So with the asteroid array, basically, if when I first started making games, basically, if I wanted to have, this is a pure example, if I wanted to have 3 asteroids, I'd write public game object asteroid 1, public game object asteroid 2, so on and so forth. And I was working on a game that had 30 enemies, so I had to write out 30 individual variables for every single enemy. Someone pointed out how annoying this would be, because what if suddenly the designer came up with 60 more enemy characters? I'd have to go in and add 60 more enemies. And writing public game object thing, even copying and pasting, you've got to change the number over and over again. And that's generally quite bad practice. So what you can do is you can use a thing called an array to basically store all of the asteroids in a list, a drop-down list. Then you can go to that list and pick a particular thing. So does anyone here not know what an array is or how it works? Put your hand up. You all do. You're professionals. Okay. So in Unity, if we wanted to create an array or turn a variable into an array, basically after the variable type, so in this case game object, put 2 square brackets. So the 2 square brackets basically says, instead of it being 1 game object, it is now a multiple amount of game objects. We have more than 1 asteroid in this array. And you can make an array for anything you want. You can make an array for audio clips, so you could have your entire playlist all saved as an audio clip list. You could have an array of transforms, of coordinates. You can have an array of animations. Anything you want, you can basically store in a particular list. So we're going to have a list of asteroids. And, instead of a list of game objects, we're going to have a list of transforms. And in this list is going to be called spawn locations array. So another thing that I tend to do is just whenever I create an array, just put an array at the end of it, so that later on when I'm referencing the array, I know what it is basically. I know what I'm referencing of that. Cool. So we're going to store all of our asteroids, all of our spawn points. and we have the time in between each spawning. So what I'm going to do is I'm going to get rid of update, because I don't need that. I'm going to delete update completely. I'm going to kind of make my own update function. And it all comes from start. So the thing that you can do called invoke. So what invoke does is it basically allows you to run a function. So for example, if I wanted to run, I don't know, create asteroid, I just use a function simply like that. That's fine. But what you can do is you can use an invoke, which will basically say, go and run this function after a certain amount of time. So it's going to say, okay, we're going to run this function, but we're going to wait 2 seconds, 3 seconds before running it. You have that little gap at the beginning. So if everything in a game is very instant, you notice on like Angry Birds when you finish it, it has a bit of a delay before it shows you how many stars you got and how many points you got and things like that. It's basically invoking a slight delay, so it's not everything is rushed. So we're going to invoke at start. So when our game starts up, we're going to invoke create asteroid, and we put that in speech marks. Then after that, how long we want to wait. So let's wait 2 seconds. Oh, 2.5 seconds even, so 2.5 F. So when the game kicks up, it's going to say, go run and create asteroid after 2.5 seconds. Now the reason why I do that is because if the player starts your game and doesn't know how to control your game, so doesn't know what the arrow keys do or spacebar and things, they instantly start playing and suddenly a whole wave of asteroids suddenly come, just destroy them in seconds. Like, we're not trying to make something like Super Hexagon here. We're trying to make a game which is actually semi-playable to an extent until you sort of learn it a bit more. I like Super Hexagon, but it is very, very difficult. So we're basically giving a little 2.5 seconds to people to get used to the controls, then bring the asteroids in. And every game does this. They always give that little gap and that little nice sort of like kind of mini tutorial time without it being a tutorial to say, these are the controls, now here are the enemies for you to use the controls against. So what we're going to do is we're then going to make our own method, so void create asteroid. And in here I'm just going to code comment, say create the asteroids, pick the spawn point, I don't know, something simple like that. Now, what we need to do is, all that's going to do is when the game starts up, it's going to say, go and run this function after 2.5 seconds, but then it's only going to run once, because it's not like update. It doesn't constantly keep running that function. So what we need to do is, at the end of creating our asteroids and doing all of our business, we then need to write, invoke, basically invoke itself. So now it's double backing on itself. And instead of after 2.5 seconds, we're going to use delay between spawning, because we don't want to leave it 2.5 seconds after every single asteroid's created. That's really, really easy. What you want to do is you want to have it, for example, 0.3 seconds or something like that. And we can play around with this in a second. And we're going to be spawning tons of asteroids like we did yesterday. It looked like popcorn. And you'll see what I mean in a second. Create asteroid, invoke, create asteroid, delay between spawning. Awesome. Cool. So what we now need to do is actually create our things. So we're going to do a couple of random ranges to basically pick a random thing inside our array. So if our asteroid has 3 items in our array, that's taking up slot 0, because arrays always start at 0, slot 1 and slot 2. So what you need to do is you need to pick a number, either 0, 1 or 2, then reference that item in the array. So it's going to randomly shuffle and randomly pick one in one of the slots. So what I'm going to do is I'm going to code comment to say, first thing that we're going to do is pick the asteroid. So inside pick the asteroid, it's going to be an integer, because it's either going to be 0, 1 and 2. It's not going to be a float. It's going to be random asteroid. And we're going to do a random.range. So the random.range needs 2 numbers. It needs a minimum number, so what the smallest it could possibly be, and a maximum number. Now the thing is with the maximum number is it's outside the pick range. So if I wanted to pick a number between 1 and 10, I'd basically set the minimum number to be 1 and the maximum number to be 11. So what that's going to do, it's going to pick either 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. And 11's kind of like the one outside it, to say it's 11's like the ultimate maximum it can't possibly be. So in my random range here, for my asteroids, can anyone tell me what the minimum is going to be? Can anyone tell me what the maximum is going to be? Do you say 1 and 3? 0, yep, because it's going to be 0, 1 or 2, and it's going to be 3 as well. Pardon? Or the length, yeah. So for this one, we're going to do 0 or 3, and next one, we're going to do the length. So it's going to pick a number, either 0, 1 or 2, and it's going to do that. So we're going to do another one of these. We're going to do pick the spawn point. So we've picked a random asteroid. We're now going to pick a random spawn point out of the 5. So I'm just going to write almost exactly the same code, so random spawn point. I'm going to pick a number, and this one's going to be between 0. So it's going to be either 0. Now, we have 5 spawn points. So in our array, it's going to be 0, 1, 2, 3, and 4. So we're going to set this last one as 5. Now, another thing that you can do is set that to be the length. So I could say, instead of 0, between 0 and 5, I could say it's between 0 and however long the array length is. So if I gave it to the game designer and I have 5 spawn points and then he says, oh, I've just added an extra 100, by the way, then obviously between 0 and 5 isn't going to make sense. Whereas if you set it to be spawn locations array.length, it's going to tally how many are in that array and basically just scale it automatically. And that's a capital L as well. It doesn't seem to like that at the moment. Okay. I'm going to revert that back to between 0 and 5. Awesome. So we picked a number for both things. Now we're going to spawn it. So we're going to do instantiate, and we're going to pass in the 3 things. So this is going to be a bit more complex than before. So with a spawn, we had just simple rocket prefab at this position, at this rotation. With the asteroid spawner, it's going to be a bit more complicated. So what we're going to do is we're going to reference the array, so all of the asteroids. And then inside square brackets, we're going to say which one. In this case, random asteroid. We're basically going to pass in which number it's just picked. Then we're going to do a comma. Now I'm going to put it on the new line so it doesn't kind of get to the end and then wrap around. So we picked, go to the array, use our number. So for example, if we wanted to pick like the second one in the array, we'd put number 1. But in this case, it's going to be random asteroid. Awesome. So the next one is the position. So we're going to do spawn locations. Random spawn point, and you see that mono developer is basically auto telling me what to write, which is quite cool. The location, and then spawn locations, random spawn points, dot rotation. Cool. So it's a bit more of a complex instantiate, but it's randomly picking things, and our game has a bit of variety now. Because if we just use the same asteroid over and over again, it's a bit boring. We're going to do things a bit more complicated. Awesome. So what we're going to do now is, when everyone's got that bit of code down, we're then going to go back into Unity, assign all the asteroids and spawn points, and then we're going to start creating the asteroids. And as we haven't written the asteroid behavior script yet, they're going to kind of like pop up and pop like popcorn, and they kind of just spawn and just sort of like spread, and it's actually pretty cool to see. So I'm going to do that in a second. Cool, no worries. So, has everyone got that code down, or do I need to leave it up a little bit longer? Everyone's okay. So we go back into Unity, and we go to our manager. Well, you'll notice that a couple of fields are now popped in. So we have delay between spawning. So I'm going to set that to be 0.2 seconds between every asteroid being created, because we want to make a game quite difficult and create lots of asteroids. Now, other games will have some form of natural progression. So in Jetpack Joyride, for example, as the game goes on, the game gets significantly quicker. So it starts off at like a speed of like 1, and then as you travel to like 1,000 meters, it then does a speed of 2, 2,000 meters at the speed of 3. And basically gets so fast you then eventually fail and you basically have to restart from the beginning again. Now in our game we're just going to leave it to 0.2 because it's all we have time to do. Next thing is that our asteroids array now has little drop-down areas. So basically we can open up that drop-down area and we have some different sizes. So if I had, for example, 20 asteroids, I can then assign in 20 asteroids in the slot. That's pretty cool. If I had, for example, 3 asteroids, I could then assign in 3 asteroids into the slot, and so on and so forth. Now, instead of getting you guys to drag and drop every prefab and every game object independently, I'm going to show you a little trick. And that is basically selecting all and dragging them all into the array automatically. So what I'm going to do is I'm going to set both the arrays to be 0. And one problem we have is if I then say, okay, I want to drag and drop all these spawn points into this array, what I can do is I can select my spawn points. Oh, right, now my manager's disappeared because the inspector's now focused on that thing I've selected. What you can do, which is a neat little trick, is basically select manager, and at the top you have a little lock icon. So that lock icon basically says, when it's on, if I select, for example, the camera, it's not going to change. It's going to stay to whatever I've originally selected. So I can now select whatever I want. I could select my scripts. I could select my sprite sheets. Basically, it's staying on that lock. So it's basically saying, I'm not going to change from this particular thing that you focused on. So now, with that lock icon selected, I can select all the spawn points and drag them drop into the spawn point array. So now we have 5 items, and it's instantly placed them. And with the asteroid array, I can select all of the asteroids in my prefabs and drag and drop them into the asteroid array as well. So we now have 3 asteroid prefabs in our array and 5 spawn points as well. And then I can unclick the lock. So yeah, that's just that little lock on the top. So you can lock it and not lock it as well. And once you've done that, run your game, and you should have tons of asteroids all spawning. They're not moving yet, but they should all be kind of like gathering together and appearing. Does anyone want me to repeat all that stuff I just said? Or is everyone okay with it so far? Awesome, cool. So, let's see what it actually does. Let's stop my game view. Okay, my editor's just going a bit mad. Okay, so basically we have a different asteroid being picked each time at a different spawn point. As they don't have any sort of behavior or rules, they kind of all spawn within the same place. And that little jitter that happens basically means it's kind of like 2 things sharing exactly the same space are going to force each other out. So for example, I can't take my iPad and put it through the table because they both have colliders around them to say I can't do that. Whereas if I put my iPad and create it at the same spot as a table in Unity, it can't register the fact that these things are in together, and it kind of then will fire them out. That's kind of like how my popcorn asteroids are doing it right now. And what I could do for a bit of fun is basically then take my ship and then fire rockets through it, and it basically pushes them out of the way because they all have mass and physics. And that actually looks pretty cool. Awesome. What's yours doing?
No idea why it's not spawning.
Okay, let's have a... what's the error? Trying to invoke method, create asteroids cannot be called. Oh, okay, that's because your function is called create asteroid. You're trying to call a method which basically doesn't exist. That's cool. Should work. I hope you have some burnt pizza popcorn in a sec. is very slow. So if you click off of that, go to manager and then set it to be like try 0 point, like try 0.5. So now I've got a massive amount of popcorn in my screen. Yep, that's cool. That's basically what they should be doing. So now they're going to start spawning in the same space as each other and basically force them out. And because your rockets basically have a velocity and pushing them in a direction.
So this one is also a rigid point.
Yeah, yeah. It's basically going to push them out of the way. So. Oh, we haven't put that in yet. We're about to put that in. But what we're going to do next is we're now going to tell the asteroids not to just spawn. We're going to make them fall and go towards the player. So we're going to give the asteroids some behavior. So that's why some funky stuff happens like that, because it's like overlapping two things. It's like I can't put this table through another table. Yeah, you could do that. So you'd have to use like a perspective camera, which basically has some level of depth. So you could do that. We're going to make them sort of drop down. Pew, pew, pew. Yeah. Awesome, cool. So now, if you look at my screen, I've kind of left it running, and I'm a bit worried to maximize this now. Okay, so this is interesting. So now if I fire some... There we go. It's a bit over the top at the moment, but at least we have asteroids coming in and they're all different and things like that. So that's pretty cool, but in the end we're trying to make some form of game. So for example, the asteroid's falling and you've got to blow them up. And actually this is quite cool, all this popcorn. And one thing that you could do is play around with it. So I could say my delay time between asteroids spawning is at 0, and it's now getting super slow because... okay, I'm going to stop that. Okay, so we have some asteroids spawning. Now what we need to do is you need to say, these asteroids, we don't want them to just spawn and just sit there, because that's kind of a bit boring. They're just going to sit there. It's going to be like shooting fish in a barrel. It's quite boring. So what we're going to do now is we're going to give the asteroids behaviors to say, instead of like what the rocket does where it moves up vector2.up, it's going to do vector2.down or minus vector2.up. So it does the opposite. It's kind of like reversing backwards, but down. But yeah. So what we need to do is we need to go to our scripts. And I need to put on my microphone. We're going to go to our scripts. We're going to create a new C# script. And this one's going to be called asteroid behavior. Cool. So we now have a C# script called asteroid behavior. Now what we need to do is we want to use the same script for every asteroid. So what we don't want to do is we don't want to make an asteroid script for asteroid 1, asteroid script for asteroid 2, asteroid script for asteroid 3, because that's 3 times the amount of work that we technically have to do. What we want to do is we want to take this class and apply it to every single asteroid that we want to do all these things. So if I select all 3 of my asteroid prefabs, select all 3 like this, if we then go into our components on the right-hand side, we can edit all the components of all the asteroids at exactly the same time. In this case, we can go to selecting all the asteroid prefabs. We can go to Add Component, Scripts, and Asteroid Behavior. We can basically say all of these asteroids now have that particular script. So we have asteroid behavior, and asteroid behavior. So we now have 3 items all using exactly the same script, which is actually a really useful thing. Cool. Awesome. So what we now need to do is we now need to go to that script and open it up. So if you go to MonoDevelop and you open up the asteroid behavior, we're now going to write a script basically for that. Cool. Awesome. So could anyone take a wild guess the first variable I'm going to make for this asteroid? I'm seeing if you guys are awake. We need some more coffee. Yes, cool. You're really going for that hat. Like, you've broken the last one already. Oh, right. Stitch them together, right? Cool. So I'm going to make public float speeds. This is how fast our asteroid's going to be traveling. Now, we did exactly the same thing with the rocket. We just made a speed for the rocket and said, rigid body 2D dot velocity, it goes up, and it's multiplied by this speed. So it's no great secret what the asteroid's going to be. Rigid body 2D dot velocity equals minus vector 2 dot up. So instead of vector 2 dot up, it's kind of doing the opposite. So it's like reversing, multiplied by speed. Bingo. So it's doing what the rocket does, but the other way around. Cool. We're then going to do some cool stuff with the asteroids, and we're going to randomize how fast it goes. We're going to randomly spin them as well. So we have some form of variety to the asteroids, so it's a bit more of an interesting game. Like, one of my favorite games is Lilac Wars. Does anyone remember Lilac Wars in the N64 or Star Fox? Yeah, so like all the asteroids are kind of like, they're not just all the same object and they all have the same behavior. They kind of all bounce off each other and they're different sort of models and things. That's the most interesting thing about it, is there's all these different elements of randomness which make the games more interesting and more fun. So what we're going to do is minus vector 2 dot up. So now if we go back into Unity and we select all three of these master prefabs, we can now edit the speed value of all these asteroids. So someone shout out a speed, not 1,000, as I know that you're about to say. 1,000, right, okay, you seem very adamant to have this ridiculous number. So, 1,001. Wow, that's a pretty fast ship. The hyperdrive is working. Cool. Right, yeah, 1001, I'm going to guess 1000 is going to have a similar effect. So basically it's just traveling too fast. So let's pick something like, let's pick 3 for example. So now what we should have is after a couple of seconds, we've now got some asteroids. Now because we have our rockets, they're basically now, we can push asteroids. That's not what they're intended to do. They're going to blow up a bit later on. We can now push asteroids with the rockets. And what we have is as well, and a couple of rockets just sort of flew back as well. So they're kind of like two forces against each other. We've got one with a velocity going down, one velocity going up, and then colliding at a certain point. So this is pretty cool. I'm now flying through space a bit slower. My asteroids, my rockets also now spin off the asteroids, which is not what it's going to be like in the end, but it's still a pretty cool thing. This is one of the things why making games with physics is quite fun, because you get lots of unpredictable and planned, basically unplanned results. Awesome, cool. Right, so that's pretty cool. I'm pretty happy with that. Now what I'm not so happy with is the fact that all the asteroids are the same speed. Now I haven't been to space, but I can guess from my TV binges of watching Star Trek, Star Wars, Firefly, the new Gravity movie. I don't know how accurate that is to actually going in space. Hopefully not too accurate, because George Clooney's there. But yeah, basically they're all moving at exactly the same speed. So what we want to do is we want to randomize the speeds. So some are going slow, some are going some are going quick, and things like that. And that's really easy to do. So all we need to do now is inside start, because this happens when the object is created, we're going to say speed equals random.range, and we're going to pick a slow speed and a fast speed. So someone pick a small number, not 1001, and someone pick a large number, not 1002. 6, okay, and we need a bigger number than 6. You're pushing the boat out a little bit. 1007? 1006? Okay, 6 and let's say 12. Right, cool. Right, let's see what that happens. So basically the asteroids are now, when they are created, I'm going to pick a speed between 6 and 12. So they're going a bit too fast for playing the game, but you can actually see like some form of randomness happening, which is pretty cool. So just by adding one line of code, we've kind of like built on top of our game. It's a bit more interesting now. I think that's too fast. So I'm going to change it to 1000. No, so I'm going to change it to between 1, because that's very slow, and let's say 4 as well, because I want some quick ones to surprise me as well. So let's run that. So yeah, that's a bit more like it. So actually, they're probably spawning. Oh, okay. So if I was actually doing a game where I have to dodge them, I probably died about 8 times already. So I'm now going to increase the spawn time, so 0.5 between them. So has everyone got something a bit similar to this? Is anyone kind of stuck or not written down the code? Are you okay? You need some help? Okay. So whilst I go help some people, what I want you guys to do is play around with the variables. So play around with the delay between the spawning, play around with how fast the rockets are, basically all these variables that are exposed. I want you to play around with them and see how you can kind of find the sweet spot in all sort of like the different values. Hello. Okay, cool. So have you all played around with the variables and kind of had fast rockets, fast asteroids, 1001 speeds? Yeah. Okay, cool. So we've got to a stage where we have some asteroids. They're spawning. They have random speeds. Some are slow, some are fast. And one problem that we have is the fact that our rockets kind of just roll off of them, which isn't what we really want. What we want to do is we want to fire a rocket. It hits the asteroids, and then the asteroids blow up, basically. And the rocket blows up, and it removes each other. So, let's do that. So what we want to do is we want to write some collision code. So both our asteroids, if you have a look at them, have a collider. So the collider is basically the wrap to say how it interacts with other objects. That's what all our asteroids have. Now the rockets have the same thing. All the rockets have a wrap to say this is how they interact with other objects. And what you can notice, you can actually notice that these missiles, or these rockets, are hitting it and then basically just bouncing off of it. So they are colliding with each other, and in some cases pushing them. But what we want to do is you want to write some code that basically, as a rocket hits an asteroid, removes each other and plays some form of explosion. So we need to write code on either the rocket or the asteroids to detect this collision. In this case, we're going to do it on the rocket. So if you open up your script for the rocket behavior, so we have things like public float speed, we've got its direction of going up. What we want to do is, outside update, we want to write a method, and this method has to be very, very precise. Yeah, so it has to be very precise, and you have to word it exactly how I'm going to word it. So on collision, enter, and then 2D. Then in brackets, we need to write collision 2D, and then after collision 2D, the collision, and then basically close that method, close that function. Cool. So those who used Unity before, briefly, if you wanted to collide two 3D objects together, basically you'd write something like void on collision, enter, and you miss out the 2D bit. That's because both the 2D physics and the 3D physics are like two completely different sets. So the 3D physics is handled by one bit of the engine, 2D physics handled by the other. And you kind of can't have 2D objects and 3D objects, like 2D colliders and 3D colliders, interacting with each other, because it's like two different things. It's like putting bicycle wheels on a car. Like it doesn't really work. Well, it doesn't. It shouldn't work. So what we're going to do is we're going to do void on collision enter 2D, collision 2D, the collision. Now there's a couple of other collision parameters that you can do, because this fires as soon as it collides with something else. So you can do an enter, so that means as it hits something, You can do an exit, so that means as it hits something it kind of goes off. So a game like Tiny Wings, when it collides with the floor, you gather up speed, and when you leave, it kind of like gives it a little push up and flies. And you have stay as well. So if you had a game where you like stayed colliding with a particular object, so for example a racing game, you stay collided with the wall, lots of sparks would shoot off, things like that. So we're going to use on collision enter because that's going to fire as soon as we hit an asteroid. Cool. So we're going to write some code to do that. So the very simple thing is removing an object. So with instantiate creating one, we have to tell it where it's going to be created, what we're going to create, what its rotation is. If we want to remove an object, we use destroy. And this is a lot more straightforward. All we write is destroy game object. Destroy. So if we write destroy game object, that means it's going to destroy itself. So when the rocket hits the asteroid, what it's going to do is it's going to say, rocket has now hit it, remove itself from the game. What we now need to do is we need to write destroy the collision dot game object. Because what happens is when two things collide with each other, this little parameter of collision2d, the collision, is kind of like a little gold mine of information. And this gold mine triggers whenever two things collide. So this gold mine has everything from what you're colliding with, where you're colliding with it with, what bit you're colliding it with, what time you collide it with. Basically, it's like this fountain of knowledge about this collision, which you can then access. So for example, the collision.gameObject will get what you've collided with. The collision.point will get whereabouts you've collided with. You can make the collision.velocity will say what velocity the other object had, or basically it's kind of like all these things you want to know about the collision. So in this case, the collision.gameObject. So we're going to destroy the missile, and we're going to destroy the thing the missile has collided with. So try running your game now. So what you should notice is it's not as interesting as before. I personally preferred it when it was kind of pushing them. But we now have it removing it from the game. So there's a couple of issues that happen here. So for example, if I move too quickly to the left and spawn missiles, this is happening. Basically only one missile gets spawned. Can anyone tell me why that's happening? So what's happening is I'm moving so fast, the missiles are colliding with each other and moving each other. So a missile is hitting a missile and removing both the missiles, which is fine if I'm doing this because they're being spawned, then they're not colliding. But if I'm traveling sideways, that's why it's getting this all funky behavior, which is pretty bad. Because in a game like this, people are going to be dashing left and right. You don't play Space Invaders and move so fast you blow up your own ship. You only sort of like fire it upwards. So what we want to do is we want to limit what our rocket is colliding with. And we can use a very simple thing called a tag. So if we go out of our game, we can write a parameter where we can find out what we've collided with using the collision, sort of like gold mine of information, and find out things about that object. So for example, we could find out what color the object is, and if it's white or red or blue or green or black or whatever it may be, then destroy it. Now what we want to do is we want to go to the object that we're colliding with and find out if it's an asteroid. Now this is a bit of a problem because our asteroids are all named different things. So if I have my game running, what you'll notice is we have, wait for it, asteroid 0, asteroid 1, asteroid 2. We've got all these different names. It's not good to basically find out what the rocket collides with and sees if it's asteroid 0, 1 or 2. So what you can do is you can do a tag to basically group things together. So Counter-Strike does this really well. So at the end of a round of Counter-Strike, basically what it does is it goes through and it cleans up the whole map. It gets all the bullets, all the bullet holes, all the enemies, all the ammo, all the guns, and just completely strips back all of that clean. So what it's going to do is it's going to look for the tag of enemy, look for the tag of bullet, look for the tag of ammo. So it doesn't matter what ammo it is. If it has the tag of ammo, it's going to get it and it's going to scrap it and basically clean the whole map for the next round. So we're going to do that. We're going to say all these asteroids have the same tag of asteroid, and this is really, really simple. So if you go select one of the asteroids, what you'll notice along the top here is we have the name of the asteroid. We've also got a thing called tag. And currently it's untagged, and everything in Unity is automatically untagged, unless it's the camera. The camera, I think, has got a tag of main camera. So if we open up this tag list, there's a couple of things already in place. So for example, we could tag all the respawn points, we could tag the finish points, we could tag all the players, we could tag a game controller, but we want to make our own custom one. So we're going to go untagged, and we're going to go to add tag. And what you'll notice is it will bring us to this menu, and we have our sorting layers we made a couple of hours ago. And underneath here, we can add our tags. So for example, I want you all to add the tag of asteroid. Nice and simple. So click there, adds tag, asteroid. Wicked. I think I have about an hour left. So what we're going to do is we're probably going to collide with the asteroids and then show you how to then build to Windows platforms. And if I have more time, probably carry on working on this game, I guess. Yeah. Cool. So tag of asteroid. That's pretty awesome. So what we're going to do now is, now that we have that tag stored in Unity somewhere, it's basically going to say this tag is now somewhere within our system. We're going to select our asteroids. So if you select all of your asteroids and go to this tag section, so we're editing all the asteroids at the same time. What you'll notice is asteroids been added to that list. If you select it, now all of our asteroids, even though they all have different names and different sizes and different colliders and things like that, they all have the same tag of asteroid. So you could tag all your ammo in your game as ammo. It doesn't matter if it's AK-47 ammo or Beretta ammo or a rocket launcher or anything like this. It's all ammo, basically. So they're all tagged as asteroid. And then now we go back to Windows. And now what we can do is go back to our code, and inside our collision code, we can wrap the destroy function, the destroy methods inside an if statement. So we can say, if the collision dot game object, so we're accessing that nugget of information, dot tag equals asteroid. Then yeah, so what it's going to do is whenever that rocket collides with something, it's going to say, what is the tag of this object collided with? If it's anything other than an asteroid, if it's untagged, it's going to ignore it. If it's the asteroid, it's then going to destroy it. So now when we go left and right, the missiles are going to collide with each other, but they're going to say, oh, we're not colliding with asteroids, so we're not going to bother we're not going to bother blowing up, basically. Not going to bother removing ourselves. So once you've written that little if statement in there, run your game and move left and right as fast as possible and try and fire some missiles and see what happens. And they should all just carry on like normal. Okay, so now that we have that in place, I did promise you guys some explosions, so actually I'm going to put in the explosions, then do all the Windows 8, Windows Phone building side of things. Cool. So has everyone got that down and got it working? Let's have a look. See, I can move left and right. I can destroy asteroids like no tomorrow. Wicked. Cool. So there's lots of other things that we could do with this game. We could bring in that audio, which actually let's bring in the audio as well. I can see how this is going to go. We're just going to keep making this game. So what we're going to do now is we're going to put some an explosion in, we're going to put some audio in, and then we're going to build it. And then it's kind of going to be left at a stage where you can carry on working on it. You can put in more sound effects, more animation, but hopefully this is kind of like the building blocks to like making games in Unity and adding components, accessing those components and things like that, and sort of having a look at the 2D tools. Wicked. So let's do some audio, because that's nice and easy. So the way that audio works in Unity is we have an audio listener, and that's always on the camera. So the audio listener is the ears in your game. It's basically listening out for where the audio is happening. And depending on if the audio is 2D or 3D, is based on how the audio listener receives it. So if it's 3D sound, so if I picked up this glass and I threw it over there, I'm not going to. I'm not going to. Obviously, that sound is coming from way over there, so it's going to be a lot quieter. If I dropped it here, it's going to be a lot louder. So that's how the 3D sound is happening from my ears, which are the audio listener. And if you want some audio to appear at a certain point in your game, you need a thing called an audio source. So you have a source that's playing the audio, and there's a listener which is hearing the audio a bit later on. So the main camera will always have an audio listener on it. Now, Unity kicks up a fuss if you have more than one audio listener. It's like, okay, you have a pair of ears, but if I had more than a pair of ears, it's kind of going to be a bit confused where the audio is coming into. So we can leave the audio listener on where the camera is. What we need to do is we need to put an audio source somewhere in our game to emit the audio from. And I've given you guys 2 different audio clips. I've got a simple explosion. I should hear lots of explosions. So I've got a simple 8-bit sound effect which I made in CFXR. And I've also got a little sci-fi audio clip. Nice and simple. So what we want to do is we want to basically have the audio clip of the background sound playing constantly on loop. So it's basically going to go play through, get to the end of the loop background. Now, because we just want it playing it, no matter where we can hear it from, where the audio listener is, we want to basically say, you are now changed from 3D sound to a 2D sound. So tick off 3D sound and make it 2D, and click apply. So audio in the game, okay, it's going to take a little while. It shouldn't take too long, it's quite a short clip. So what this is doing is it's basically saying, you're no longer 3D, you're now 2D sounds. Now, that's going to play regardless of wherever it is in the game. We also have the explosion SFX. So as this is a 2D game, and we don't care about where it is playing in the game, we can untick 3D sounds and click apply. So 3D sound, well, they're both 2D sounds now. Cool. So this background music, and we have the sound effect. And it's going to be fairly obvious when the sound effect happens. So if you select the manager, I keep saying that the manager is one of the most important game objects because it holds all the things like your points and your audio and things like that. So if you select the manager and you add the component of an audio source, so select the manager, go to add component, audio, then audio source, what you'll notice is that we have a bunch of options basically saying this is going to be a source of some audio, play some audio from here. And we have a couple of things that we can set. So do you want it muted? Well, obviously we don't. Do you want it to have a reverb zone, so it's like in a cave and it echoes? Do you want it to play on awake? Because that means when the game starts up, do we want it playing straight away? And yes, we definitely do. Do you want it to loop? Well, obviously. We also have a level priority. So whenever I use any background music, I always set its priority slightly a bit lower, so perhaps like 100. And I always have all my sound effects, so explosions and things, slightly louder, because I don't want my audio to drown out the actual things happening in my game. We have volume and pitch and things like that, but that's okay. So currently this slot is completely empty, so we have a none, we have no audio clip in there. So what we want to do is we want to select our audio, go back to the manager, select our audio and drag and drop it into that little slot, like so. And what you'll notice is that this audio source is now going to play the sound. It's a 2D sound. It's going to play on awake, and it's going to loop. So after you've done all that, play your game, and we should have some background music to our little game. Funky music. So I was kind of half expecting lots of different, like this same clip playing from lots of different locations. Which has happened before, but yeah. Cool, so we've got some background audio, and that's fine, that's cool. It's kind of given us a bit more character to our game, as opposed to just firing rockets and blowing things up. What we want to do now is we want to have every time one of our rockets hits one of our asteroids, it's to play that little explosion sound effect, so that little 8-bitty sort of retro sound effect. And this is really, really easy to do. So what we need to do is we need to go to our rocket. So if you select our rocket in our prefabs folder, what we need to do now is we need to tell that to be an audio source. Because it's going to be emitting sound from wherever it is in the game, we need to go down, we need to add a component of audio source. So go to audio, audio source. So now you can see that our rocket, which started off as just a very simple like one image sprite sheet, now has animation, now has physics, now has a behavior to fly and collide with things, has a collider, animator, and now it has audio coming out of it. So you can see how building against Unity is just building up all these components. But we need to change some things. So we don't want the explosion to play when the game begins, because that's not going to make any sense. We don't want the explosion to loop, so that's fine. And we want to set priority sort of a bit higher. So that means it's going to play over the top of the background music, which is a good thing to have. Cool. So what we need to do now is we need to go into our code for the rocket behavior, and we need to add in 2 lines of codes to play some audio, which is fairly simple. So what we need to do is underneath our speed, we need to add a new type of variable called an audio clip. Call this explosion SFX, like so. And can you tell me where this is going to go? Where are we going to play the audio? Yes, excellent. Inside or outside that little if statement about the asteroid? No, it's okay, didn't hear. Okay, that's cool. Yeah, that's exactly what we're going to do. So we're going to drag and drop the audio clip into that variable, then we're going to call it later on. So like we call rigid body 2D to get the 2D stuff, what we're going to do is we're going to write audio source dot play clip at points. We're going to play it at this exact point. And then inside these brackets, it's going to ask for 2 things. It's going to ask for what audio you want to play and where you're going to play it. So we just have to position it somewhere in the game. So even though it's a 2D sound, it's basically going to say play it wherever. If we had a 3D sound, this would be a bit different. We'd have to say play the audio wherever it collides. So you'd use the collision.point to get the point in the game it collided with. So at the moment, as it's a 2D sound, it's a 2D game, it doesn't matter too much. So explosion SFX, transform.position. Cool. Very simple. So 2 lines of code to bring in a nice little sound effect into our game. So has everyone got that bit down? I guess so. Everyone's quiet, so that's cool. They're waiting in bated breath for the audio to actually play. So if you now select the rocket and go to the script, so you notice in the script we now have a little audio section here to drag and drop some audio. So don't get the background music because it's going to layer the background music every time it collides with anything. Drag and drop explosion SFX into that little slot. So now for our rocket behavior, for our prefab, we've got speed of 4, we've got explosion SFX, and yeah. And what you should have now is some asteroids at some point. Very simple. Has everyone else got some form of explosion sound effect playing in their game? I saw a smile, so I guess yes. This one. The audio source is kind of acting like a jukebox, like you can't play sound without a thing to play the sound. So in this one, you are basically accessing this audio source to then output it through there. What we could have done is we could have used the audio source on the manager, but that means we've got to find the manager, find its audio source, and then play the audio source from that point. Yeah. I hear some explosions over there. These guys are pretty quiet. It's all on mute, right? Cool. I can hear... He's nodding and laughing. Pardon? You say it's a stupid game? So yeah, you could do a free-to-play and say you get explosion particle effects only if you pay 69p, right? Cool, awesome. So we have our little game, and we have that. So I've got, so Microsoft dudes, is it 5 o'clock that we definitely finish, or? Cool, thank you. So we've got probably 2 more things to do. So one thing we have to do is put in our little explosion effect. That should be quite quick. The other thing to do is build to Windows 8 and show you how to do that process. I'll find out from the guy. Okay, right. So finish when I finish, but it has to be 5. Okay. Okay, cool. So we've got 40 minutes. Let's. Okay, yeah, let's do it. Let's go for it. So we have our rocket, and what we have here is we have our rocket. We've got one clip of it flying, and we've got its controller. So what we want to do is we want another animation clip. So we want to go to Create, a new animation, and inside this animation, call it rocket _ explode. So we now have 2 clips. So you can see in a normal game with like a character that runs and jumps, not a stupid game as you put. So a character that runs and jumps, you'd have like an idle animation, a walk, a run, a punch, shoot, whatever it may be. So you've got rocket flying and rocket explode. And it's fairly self-explanatory what this is going to do exactly. So what I want you to do now is go to your sprite sheets. Where's the sprite sheets? Yeah, go to the sprite sheets, and what you should have is you should have a sprite sheet called Explosion. I'll zoom out a little bit. So a sprite sheet called Explosion, and you can see in the little preview it goes through a series of frames of something exploding. So what we want to do is we want to go to the texture type at the top of this sprite sheet, change it to a sprite, change the sprite modes to be multiple, which we've done many, many times before, change the pixels to units to 30, and click apply. So this is, we've done this like 3 times before, I guess. So yeah, sprite, multiple, 30, apply. So nice and straightforward. So once you have that all down, open up the sprite editor. What you'll notice is we have something very similar to the rockets like we had before. So the rockets basically had a series of frames, like a grid, and we're going to cut this up exactly like we did with the rocket. So if you go into the slice options, and you go to grid, what we need to do is you need to put in how big each frame is of this particular grid. So, you have X-ray vision or something through to my iPad, right? Or you've tapped it in. Yeah, it's 39 by 38. It's actually supposed to be 39.5. But you can't have 0.5 of a pixel, so 39 across, and then 38, and we're going to slice that. And what you can see is now it's cut up all the individual explosion frames, and it's got it all in a grid like that. So hopefully everyone's got something similar to that, or... Cool, 39 by 38, and then click apply. Cool. So what we should have now in our project is explosion. We've got a series of explosion frames, so 0 to 12, and we're now going to use those for the rocket. So what we need to do is we need to go to our window, we need to go to our animator, and we need to bring one of the rockets into our scene. So you remember that I was talking about those spider webs? We basically need to select our rocket, go there, we need to see something like this. So make sure you have something that looks a bit like this. So we have rocket flying somewhere within our animator window. Cool. And we need to drag and drop in rocket _ explode. So ultimately you should have something that looks like this. So we have rocket _ flying as orange, rocket _ explode as grey. So like I said before, the orange basically says this is the first animation that's going to play. So in terms, the rocket's going to be flying along as normal. What we then want it to do is do that transition to explode when the rocket hits something. So we want it to go down and play that clip of it exploding. And this is really easy to do. So currently it's unbroken. There is no chain between them. But if you watch, it's really easy. So you just right-click on the rocket_flying, click Make Transition, and we now have a little handle to basically draw wherever that transition goes. So in this case, I am going to drag and drop it to rocket_explode, and it should snap on automatically to the center of it, and click that. So you should now have some form of wire like this. Put your hands up if you don't have a wire or it's gone a little funny. Cool, awesome. So what we have here is we have a transition. So basically this transition is like a gate. It's like a doorman saying you can't go through here unless you have a ticket or unless you have a certain amount of money or things like that, or can't come through here for any reason to this rocket_explode. Now what we have here under this transition is we need to give it a trigger. We need to write something in the code that says when the rocket collides with the asteroid, go to this bit here and then trigger off the explosion. So we're going to click the plus symbol in the corner in the parameter section, click plus, go to trigger, and we're going to write explode. So a trigger is basically a one-way thing. It's going to say when the player clicks a mouse, go down, play this animation, and it's going to do that. And you can see kind of like this is like the most simple animation you can do in Mechanim. You can see how you can start adding extra things. So you could have rocket flying goes into rocket. Instead of exploding, flashing red, you can make it flash blue, resize, rotate. You can make all these different transitions. So what we're going to do here is we've made now a trigger of explode, which we're going to reference in the code. Cool. Everyone okay with that so far? Awesome. Let's continue making our stupid game, as you put. Cool. So what we're going to do is we're going to go back to our scene. So now that we have two animation clips on our rocket controller, if we bring up our animation window, where is that? And dock it to the bottom, and select our rocket, what you'll notice is that we now have an extra thing to our drop-down list. We have rocket flying, which is just going to play through like you normally have a rocket flying, where it has the flame sort of cycling through. And we also have rocket_explode. So what I want you to do is I want you to switch to rocket_explode. So the more animation clips you have in here, the longer this list will be. So rocket_explode. And we're going to do exactly the same thing we did as rocket flying. So we're going to go to Add Curve, Sprite Renderer, and we're going to go to Sprite. So underneath here, basically, we're going to say delete the last frame, because we don't want our rocket to end up exploding, then turn into a rocket again. That doesn't make any sense. We want to delete the last frame of the rocket, go down to our explosion frames, and from about frame 3 to frame 12, drag and drop them in. So I know I'm doing this pretty quick, but it sounds like I have a time frame, and we get kicked out at some point. So what you should have now is you should have a series of frames basically playing an explosion like that. Anyone have anything similar? It's exploding a bit too quickly, but that's okay. We can manage with this. Okay, awesome. That's very, very quick. So again, what I'm going to do now is, like the rocket where it's exploding a bit too fast, the sample rate's at 60, so that probably needs to be probably like a quarter of the speed, I guess. So I'm going to set the sample rate from 60 down to 15, and it spaces out a bit. And now we have a bit of a better explosion. So now it's actually exploding. We can actually see it doing its business. Okay, cool. So we have all our building blocks for our whole animation system. We've got a rocket flying. We've got the rocket animation playing. We've got the rocket exploding playing. Where that transition between the two, we've got that trigger and the code to send off to it. Now we need to set that transition to link to the trigger. So I know this is kind of getting a bit more confusing now, but hopefully it will make all sense in the end. Our stupid game will get better, I promise you. So now that we have all of the bits in place, We then have to go to the most important part of the system, and that's this line. So this line is the thing, the gatekeeper basically saying, go and play this rocket explode. And if you select that line, what you notice is it turns blue, and the inspector on the right-hand side has a bunch of properties. Some of these you don't need to worry about, but the one you do need to worry about is the conditions. So like when you go into a gig, for example, you have gig tickets, obviously. The condition that you get in is that you have the gig tickets or you have the amount of money for the gig. It's kind of like the thing that says, this allows to go through. So currently it's got an exit time. We don't want that. What we want to do is we want to open up that exit time and go to explode. So the condition of it going down this path is if explode is called in our code. So if we write set trigger explode, it's then going to go and explode, basically. Cool. Everyone okay with that so far? I know I talk very, very quickly. You're shaking your head. I'm a bit worried. Are you okay? Or do you have this line in between these two bits? Okay, select. Yeah, select that line, and on the right-hand side should have the explode bit there. Okay, awesome. Cool. So what we're going to do now is we're going to write a bit of code, and hopefully if everything's gone right, our game is now going to run and be fine. So yeah. So let's go back to our rocket behavior. So our rocket behavior is going to go through, and when it collides with the object, it's going to destroy the object, destroy itself, then play the audio clip. Now what we want to do is we want to access that animator component. So what we're going to have to do is we're going to have to write a private variable called animator, and let's call this anim. Then we're going to have to write a function called void start. And then in void start, we're going to have to say, get the animator and basically store it for later. It's kind of like store it in a piggy bank for use later. So it's going to say, go to the anim and save that component. It's very simple. Then one last thing that we need to write, and then our whole animation system works, is we don't want to destroy a rocket, because if we're destroying our rocket, no animation is going to play, because that's what the rocket is playing. So we delete that destroy game object line, and we're going to go to anim.setTrigger, and then we're going to say set trigger of explode. And that's kind of like where everything comes together. So we're literally just saying, go to here, go through this transition of explode, and play this. So I've added that bit. That bit, and anim.setTrigger explode. So when you've got that all down, run your, as you put it, stupid game, and we should have an explosion happening whenever the rocket collides with an asteroid. Cool. Right, I'm just going to test that mine works. There we go. Cool. Has anyone gotten that not happening? Right, okay. A couple of dudes. Oh, yeah, sure. I'll open up the script. Okay, cool. So we now have explosions in there, and we've got all the building blocks for our game, and that's kind of how far we're going to take it. So now what you can do is you can then take this game and carry on developing it, working on it if you want to. This stupid game as you put, and make it a not stupid game, I guess. And hopefully sort of from the things that I've shown and things that you shadow me making, basically you can see sort of how Unity works and that you have all these components linking up and being referenced in the code. So one of the most important things of game development is, after making your game, actually releasing it on something. So what we have here is we have Unity's own project. And the way that Unity works is that you build your project to wherever you want it to go. So if you want to build it to Windows Phone, You select Windows Phone, build it to that. It then takes the project, wraps it up in a nice bow, does all the bundling for you, and then it exports a Windows project. If you wanted to build it to a web player project, it then bundles it all up, preps it already, and exports a web page project. So basically, it then bundles up all the things from Unity, all the assets, and then it pushes them to wherever you want it to go. So if you go to, so put your hand up if you've set up a Microsoft developer account. Okay, 2 dudes. Put your hands up if you have the Windows 8 Phone SDK, or the Windows 8 SDK even installed. Okay, cool. Put your hands up if you have Visual Studio Express for Windows. A couple of people. Okay, so some people it's not going to work, some people it's going to work. That's fine. It might be best then if I build it through on screen and show you guys how it all works. And it's very straightforward. So if you click File in the top left-hand corner and go to Build Settings, what you have here is you have kind of like the end of sort of like the Unity development. You have all the things that you've built up in your game and the locations it's going to go to. So we have Scenes and Build. So currently we have no scenes. So if I just built this, it should be completely blank blue, and you'll think you have a blue screen of death, basically, if you put it on the store. So what we want to do is you want to click Add Current. So Add Current basically takes whatever scene you currently have, and it sticks it into here. So by the end of your game, you should probably have like an intro screen, a level select screen, a main menu screen, a main game screen, and all sorts of things like that. Then we have here our list, and this list is ever growing. So for example, when if you get accepted onto the Xbox ID program, you'll have an Xbox One bit here, so on and so forth. And basically, you can see that we have a whole bunch of things we can build to. In this case, a Windows Store app. Next thing we need to do is set a type. So D3, D11 is basically just a simple Windows 8 Store app with a layer with the Unity layer put on top of that. It's a lot more performant, a lot more optimized for devices, but that's pretty much as you get. It's kind of like the simplest build you can. Now, XAML, when it builds that, allows you to then go into Visual Studio and kind of tweak things more. So if you want to access your photo library or your audio playlist from Unity, build the XAML one, because it allows you to then go in and tweak things a bit further. So in this case, I'm not going to build a D3, D11. I'm going to build XAML C# solution. So I'm going to select that. Next is your SDK. So I'm currently running Windows 8.1. So I'm going to drop it from 8.0 to 8.1. So that's what I'm going to build to. Cool. So now before I build it, which I'm not going to do yet, I'm going to go into player settings. So player settings here allows you to tweak things a bit further. And it's a bit more platform specific. So for example, if I was building to Windows Phone, it will say whether it's portrait, landscape, auto rotates, things like that. If I wanted to build it to a web player, it will say how big is the web player in the screen. What I'm going to do is I'm going to click Player Settings, and in the inspector on the right-hand side, we have a couple of options here. So I'm going to say what my company name is. So I'm going to put Unity Tech. Completely spelled wrong. Product name, so I'm going to call it Asteroid Blast. Then next down here, we basically have our list. So we have things like, you can recognize the Android logo, iPhone, we have Windows Store app, and we also have a Windows Phone as well. So in this case, we're building to a Windows Store app. Now some of these sort of like sections are available. So some things like resolution presentation, as we're building an app that's going to be on desktop, we don't need to state if it's going to be like portrait or landscape. People aren't going to be picking up their tablet or their desktop monitors and basically rotating it. If you're building to Windows RT or Surface, you probably would do, so then you have to tweak that in Visual Studio. So if we go through icon, splash image, other settings, none of those things are sort of really useful for us at the moment, but publish settings is where it's important. So what you'll notice in publish settings down here is this is kind of like setting up all the tiles. In Unity, you can set up all the tiles and all the things and drag and drop all the images you're going to use. So the first thing that we have here is package names. This is basically the bundle that it's going to end up exporting. We then also have the logo. So if I go through the Windows 8 interface, the logo is this icon here. So if, for example, I was building Visual Studio app or I was building, I don't know, Paint, I drag and drop that logo into that selection there. Now, the next one that I'm going to do is, so if I select that logo, it's going to bring up my files, all my files inside my project. Underneath app icons, I've got Windows Store icons, and I have my Astro logo 50 by 50, and it must exactly be this size. That's very important. If you set anything other than that, basically what it's going to do is Unity will throw up a thing saying, it's not 50 by 50, please upload the right size, you fool. It won't say that, you fool bit. So I'm going to set 50 by 50, and what you'll notice is it's got that look up to that logo. We can pass the certificate. Next one is the description. So description is kind of like what your game's about. You can edit this in Visual Studio, which I'll do a bit later on. So actually, I'll edit it to just show you Unity carrying these things across. So I'm going to say, blow up some asteroids. Something very simple in the description. The next thing is the tiles. So if I go into here, the tiles are what's going to be on the startup. So for example, this is a medium tile, whereas this down here is going to be a small tile. This is a wide tile. This is a large tile. And what you can do is you can put in images, and it'll swap out those images based on your tile. So for example, if I take this, the game controller, and make this, resize it to be, for example, a medium tile, it swaps it out for a slightly bigger image. So if I have this person drinking a cup of tea, or a cup of coffee, and I basically resize it and say, you are now a small tile, it's going to swap it into be a heart shape. And in Unity, you can basically set up all of these bits and pieces, and it will carry it all over in the build. So I have a normal size logo, and in sort of all the option, in all the files that I gave you guys, I've basically made all these logos already for you. We have the wide logo option, so in this case, into the app icons, the wide logo, small logo, so into app icons, I've got the little small close-up of the asteroid. Short name, so this will be if your app logo is so small it cuts off the end of your name. So, for example, TT Games have just recently released Lego Marvel Superheroes. Obviously that's quite a long title, so they'll probably say when you have a small tile, drop it down to just Lego or LMHS, I guess. So in this case, I'm going to drop it from Asteroid Blast down to Asteroid. I can then say when it shows the name. So I'm going to say show it for all logos, say what color the text is going to be, so in this case light, what color the background is going to be, and I'm going to leave it as black. The next is a splash screen. So if you don't set anything here, the Unity build will basically just put in a powered by Unity splash screen that pops up for like a couple of seconds. If you do set something there, it basically overwrites the logo, the splash screen that we're setting for you guys. So if you select in there, I've made a very pretty splash screen saying Asteroid Blast. Next thing is background color. So the default will be black. So I can overwrite this to whatever color I want. So I'm going to leave that as black. Then down here is other bits and pieces. So if I wanted to access the microphone properties, I'd then tick microphone. I'll be able to access those things. These are kind of all if you want to take your game and have internet clients or servers or music libraries and things like that. So I've prepped up all my game. I've fed it all the tiles and things like that. They're all included in the Unity build. I have my scenes in there. My game is all finished. Then I click build. So now it's going to ask me where to build it to. So I'm going to make a brand new folder called Asteroid Blast Win a Build. And select that folder, and I'm going to build it. So what Unity is now doing in the background is it's basically going to get your project, package up all your assets, tie them all together, basically prep them for the native code that it's going to read on the other end. So if you're building a Windows Phone, it's going to create a Visual Studio project with the solution file and all the things that you play around with in Visual Studio to then build it to your end device. This process tends to take... it tends to be more dependent on what you're building to and what's actually in your file. So obviously if you have 1,000 images all 1 meg in size, that's going to take ages to build. Whereas if you have one image of 1 meg, it's going to take a lot shorter time. Audio tends to take quite a while to sort of all bundle up. For example, building to like a web player build is a lot quicker than to building, for example, to Windows Phone 8. I think Windows Store apps and Windows Phone 8 are about the same length of time of build time. But yeah, now we're building. Has anyone got any questions so far, or? Nope, that's all cool. If you want to email me any questions, probably what I'm going to do after this week's over is I'm going to polish up the game a bit more, add a bit more code and things like that. So things for like Windows Phone, like some text input code and things like, and basically like pretty up a bit. Then I'll probably zip up that whole Unity file and then send it to Drazen or Yuka, and then he'll be able to send it out to all the attendees when that's finished. So you can kind of see like everything rounded up. So when it's finished, it will basically show me where my Windows 8 build is made. I can open up that folder, and I've got my Asteroid Blast, and inside here it will have a load of gibberish, where it looks like gibberish. But this is kind of like everything. It's kind of got like the layers for Windows 8. It's got the Unity things. It's basically all your app builded up into a thing that Visual Studio recognize. But you'll have three files. You have Asteroid Blast. You'll have the players to then play it within your, after you installed it. And you have this top file, so this top Microsoft Visual Studio solution file. So you open that up, it will say open up Visual Studio, and then you can build it to whatever your device you have plugged in or onto your remote desktop. It's just going to open up. Normally it doesn't take too long. Cool. What it's now going to do is it's basically going to get that native code that Unity is then packaged up for you. It's then going to put it in a basically a state that Visual Studio can read it in. So who has used Visual Studio before? Okay, cool. So it's now just packaging it up, and now it's done. So in Visual Studio, you have your solution file on the right. Solution file is kind of like the top file that shows you all the things within inside that project. So like in Unity, we have our project file, project window, at the, which I've docked here, which has got all the things inside my project that I'm using. Visual Studio is kind of like the same. It's got all my things here. Some of these things you don't need to worry about too much. So we have here our properties. So the properties are kind of like all the extra bits and pieces we can play around with. We have our references. These are going to be all the libraries. So you can notice here we have the Unity Engine library to render it. We have the delegate, the thing to then play the Unity Engine. We've got the Windows library. We've got the Boo library. We've got all sorts of things. I wouldn't recommend deleting any of these because your game will probably break when you build it. We also have the assets. So the assets are all the tiles. And if you notice, if I hover over them, Unity is carried across all of these tiles. And it's renamed them to be splash screens, square tiles, store logo, all sorts of things like that. We also have the data file. So this is kind of like the big build-up of all the Unity. So everything that Unity's packaged up in your game will be inside this data file. Now, if you delete that, you basically lose your whole game that's been built. Now, if you want to build your game to Visual Studio, and then say like I think, oh yeah, I forgot to change something earlier on, you can go into Unity, select this file, and it will just overwrite that data file. All the other things get kept. So that data file is basically the thing that goes overwritten each time. You don't have to create a brand new project every single time. We have the app example. So if I open that up, we basically have, you can actually see what the app is doing. So for example, it's going to, on launch, it's going to run some events. It's then going to make it the current active window. It's going to do the app callbacks. It's going to remove the splash screen after it needs to. You can actually see what it's doing all the time. So for example, if you're making a game where you get a high scoreboard from like Azure or somewhere, what you can do is you can, in here, when the player boots up the game, you can then send off a function to go find that high scoreboard. So the one thing that we do want to look at is this package.appxmanifest. And open that up. And we should have something like this. So this is kind of like a summary of all the visual properties and all sort of like the background bits and pieces of your app. So we have our display name. You notice that I've accidentally put an equal sign in there, so I can get rid of that. We've got our entry point of what our .app is. It's carried over the description that I put in Unity. So a lot of these things are carried over from what I filled out previously. If I go to Visual Assets, what you'll notice is that Visual Assets, if I switch it to the square logo, it's carried in my asteroid logo. Wide, it's carried those things in. So, for example, you don't have to set up these things in Unity. You can just go in, bring them all into Visual Studio and just sign everything up and reassign them. Store logo, all sorts of these things here. And we can set up the background color. Cool. We have capabilities as well. So if you want to access the location of your player, so you're doing like a geolocation game, you have a lot more fun things to play around with. But what you want to do in the end, ultimately, is this section at the top here. So we actually want to build it. So we now have our Visual Studio project. We have what we're going to build it to. So this is basically the architecture that's going to run your project. So ARM is if you're building to like Windows Phone or to Windows Surface, whereas x64 and x86 are if you're building it to a desktop app. In this case, we're building a Windows Store app, so we're building it to x86. We have debug modes, which will basically show any errors that will pop up in a little log at the bottom. Release is what the player is going to then have at the end, so you can test that out. And master is going to be the one that you build that you then send off to Microsoft for submission. And the last thing is we click local machine. It's then going to get our Visual Studio projects. At the bottom it says build started. It's then going to compile. It's basically now going to install it on my machine. I'll have a little tile. I'll have a little app icon. I'll be able to then test out my game. And as I'm doing a debug build, it does a very quick build. Whereas if you build it to like release or master, it kind of packages things up a bit more. Whereas debug build is like for quick iterative development. And if I have any errors in my code, basically, it'll point them out. So whilst it's doing this, it shouldn't take too long. Yeah, cool. It's now deploying started, checking the files. What it should do is if you leave it, it should automatically install the project. It will say something like, oh, deployment complete, build finished. It will then automatically kick up the game. There's my splash screen with my lovely blurred out asteroid. We have the splash screen, we have the background color I specified in Unity. And then it will kick into the game, and then I can go blow up some asteroids. So now I have my game. I'm playing my game, all in here. You notice that when we put these spawn points just above where the camera view was, it's basically taken that perspective into consideration. So we can explode some asteroids. Now the thing is when you build a debug build is that audio kind of gets a bit choppy. Okay, it's not doing it now. When I want it to be choppy, it's not being choppy. Kind of gets a bit choppy. So if you want to really test the audio, probably best to build like a master build or a release build and then test it through there. So we'll play our game. So now if I then close my game, close my game, what you'll notice is that it automatically adds it into my app list. So you've got Asteroid Blast with my little logo that I put in, and I can click that and it'll basically reopen my game. We also have the tiles as well. So what I've got here is my asteroid tile. So you can see that it's basically shortened Asteroid Blast to asteroid because the blast bit was going to be missed off. You can then resize your tile. So if it's going to be wide, it's going to swap in for that tile I made where the asteroid's kind of a bit more central. And if I wanted to resize it and it's small, it would be a tiny little icon and it's now missing the text. And it's kind of swapped out, like this health and fitness one as well. But if you hover over it, it's going to tell you its name. So yeah, that's basically the work through building a game. So we've just all built a game together. You're all technically now game developers, which is pretty cool. You've now made a game. If you want to build to Windows Phone, it's exactly the same process. If I can do it in 8 minutes, I'll do it in 8 minutes. It's pretty much exactly the same process. All you do is you go into Unity, go to File, Build Settings. So now we're in Windows Store Apps. We then click Windows Phone instead and switch the platform over to Windows Phone. So what you'll notice that little Unity logo will now swap into here when it's finished sort of like compiling. It's now prepping things for a mobile sort of environment. If I can find my phone. Should do it. Oh, it's taking its sweet time. Okay, it's taken a little while. So if you want to build a Windows phone, all you do is you do switch platform to Windows Phone, build out another project into a different file. It'll give you exactly the same file structure as you would with Windows 8. You open up that solution in Visual Studio and build it straight to your phone. It's as easy as that. And then in Visual Studio, you can then tell your app what tile it's going to be. The other thing is with building things for Windows 8 and Windows Phone is Unity handles a lot of mouse inputs and things like that and clicking and it transforms them into taps. So if you did something like on left click of mouse, blow up an asteroid or something like that, what it will do is in the compiling stage, it will basically go over, turn that into a tap, and it will do that. So you don't have to rewrite your code. You can basically use all mouse inputs, and it will then convert those all over. Now I made that, and let's do a build quickly. All right, okay. I've got to do this in the next couple of minutes. Cool. It shouldn't take too long. So has no one got any extra questions? Anything about Unity in general, or building to Windows devices or platforms? Okay, so change ARM. So you're building to your desktop, right? Okay, so ARM is for Surface and mobile. You got a whole bunch of errors. Probably Visual Studio. Where is it? Oh, if you're going to analyze. Not there. Configuration manager.
That one was on ARM. And then it built fine, but without any errors when I couldn't deploy it. But when I changed it to like 64,
Oh, yeah, cool. So now if you build it to your local machine. Whoa, you got 10% battery. So far, so good. Cool.
yeah, well, I was kind of thinking I'm running 64 Windows.
Did it not install it? Oh, yeah.
There we go.
Yeah, there we go.
And then I had another question. I never got the explosion.
Right, okay.
The code is in there. It looked exactly like the other one. It just didn't exactly explode.
Okay. Okay, that's cool. Okay.
I tried.
And oh yeah, okay. Basically, you're destroying your object after you. Yeah, yeah. You're basically destroying it. So let's test. So you need someone to open. That's not part of the game. There we go. Awesome.
Thanks.
Cool. And then you just... Thank you. Okay, cool. So, has anyone got any questions? I know I've asked that a couple of times, but maybe something? You got maybe a question?
All right, so that was it for today. We hope you had fun and learned something today. We'll send you a follow-up email. You'll find all the resources, the recording of this event, a summary of all the stuff that we talked about, Bespark, Level Up, Develop Up, God knows what, ups here and ups there. If you happen to need more devices, testing devices, learner devices, Windows phones or tablet devices, let us know. You'll get our contact information in the follow-up email, or you can just contact Mereta, who already sent you a bunch of emails before this event. Thank you all for attending, and thank you, Andy.